Hi, I am Taher Galeb. In this talk, I'll be presenting our study on the impact of noises in build breakage data, in continuous integration in particular. Continuous integration, or CI, allows developers to automate software builds, which offers them the opportunity to identify bugs at early stages and compile and test their code changes under various runtime environments. CI builds are not always successful. They may break due to errors while installing dependencies or failures while compiling or running tests. However, these breakages are not always related to developers' activities. They can be incidental, which can introduce an overhead as developers may require to wait for the person who broke the build to fix it, or they may have to do unnecessary changes without being able to fix the breakage. Let's take the following example. We can see here a bunch of broken builds, which may tell us a story that when the first build got broken, developers attempted to fix it until they got it right. However, when we take a deeper look at these breakages, we see a different story. We notice that some of them are actually due to the environment, not the actual code changes. We also notice that these breakages are just cascading the very first breakage. Therefore, all such breakage can introduce noise as someone may associate them to the code changes. Here is another example where certain build jobs cause the build breakage, but we notice that developers may deem these jobs as noisy at later stages, which may indicate that they were not broken because of the code changes. And if they were excluded earlier, build could have passed. Hence, these breakages can also introduce noise to build breakage analyses. In our study, we investigate the three types of noisy build breakages: environmental, cascading, and allowed, and then we study the impact of such noises on finding of prior research. To do that, we took the Travis Turing dataset and select projects that have over 1,000 builds to end up with 153 projects with enough data for our analyses. We took also another dataset from a previous study on build breakages. Using these datasets, we performed manual and automated analyses on build logs to identify the amount of the three types of noisy build breakages and the categories of such breakages. Then, we cleaned the datasets and fit regression models for the data before and after cleaning to find out the impact of noise on modeling build breakages. Our results show that 55% of build breakages in our dataset are noisy, meaning that they are unlikely to be related to developers' changes. We identify 16 types of environmental build breakages, with the majority of them being caused by internal CI errors or external connections or running out of time or space. 66% of these breakages are exclusively environmental, meaning that developers have no control over them. And in 15 subcategories of these build breakages, developers may find a workaround to fix or avoid such breakages, such as increasing the timeout limit. When modeling build breakages without the noise, we observe an enhancement to the modeling performance, AUC, by 6%. And we find out that noise could make models sensitive to the language, project, and build age. We also found that noise can also lead to misleading associations between build breakages and other variables like the time of day, car developers, and team size. We also observe that findings of a prior study may not hold. For example, the study we took found that no significant effect of the day of week and time of day on build breakages. But after removing the noise, we find that there is a significant effect of these variables. The study also found that pull requests cause more breakages, but excluding the noise shows that integration and merge commits cause more breakages than pull requests. Moreover, the study did not find any evidence that file types are associated with build breakages, but removing the noise has revealed that system files are actually associated with build breakages. Finally, the study found that developers who commit less frequently cause fewer breakages. But we also found that daily committers can break fewer breakages as well. To conclude, our findings imply that developers should consider restarting builds when they have unexpected breakages. And also researchers, they should perform a careful data cleaning when conducting studies on build breakage data. And finally, CI service providers should consider enriching feedback to developers with more details about the build breakage. Here's a summary of the key points of our study, and more details can be found in our paper published in TSE. Thank you.